All right, today we're going on a mission. We're going to investigate a somewhat elusive topic, but one that has a huge impact on industrial performance, the so-called hidden costs. Imagine a leak. Not a water leak, but a leak of money. This is exactly what is happening right now in an incredible number of factories. This invisible energy waste comes directly from electric motors and quite literally vanishes from the balance sheets. To fully grasp the scale of the problem, you need to look at this figure. It's simple. Almost 30% of all the electricity generated worldwide is consumed by industrial motors. That's just phenomenal. And the worst part of it all is that a huge proportion of this energy is lost and wasted. All right then, let's dive straight into this investigation. It's important to realize that even the smallest improvement in engine efficiency has a measurable and immediate impact on costs. That's the first step, turning what was once an unavoidable cost center into a genuine source of savings. The key point here is to fully understand what we're targeting. Our culprit is that infamous non-productive energy. In simple terms, it's the energy that a company pays for, but which never actually keeps the machinery running. It's like throwing money up in smoke, and it's precisely this loss that we can finally track down. But then, how do we actually go about it? For years, our approach was, let's face it, rather basic. The contrast with what we can do today is simply striking. On the one hand, there's the old method. Essentially, we wait for a motor to fail, replace it somewhat blindly, and in the meantime, production grinds to a halt, costing a fortune. On the other hand, we have the new, much smarter strategy. Based on real data, it enables us to act with surgical precision without ever interrupting the production line. This new philosophy boils down to a simple yet highly effective approach: measure, correct, save. First, we measure to obtain facts and concrete data. Then, we correct the energy leaks that we have identified. The result is a virtuous circle of direct savings and the ability to anticipate problems long before they turn into disasters. That all sounds good in theory, but how do we put it into practice? In order to see what is invisible to the naked eye, you need the right tools. Diagnostic tools that act as the eyes and ears of the modern investigator in the field. So the question has been asked, and the answer, well, lies in a new generation of measuring devices. In this toolkit, we have two standout products. The first is the CA8345. Think of it as a specialist doctor that carries out a full checkup and provides a highly precise, one-off diagnosis. And alongside it, we have the PEL113. This one is more like a health monitor. It's there to continuously monitor vital signs over the long term. They have two different roles, but they complement each other perfectly. And here's the crucial point that changes everything. Gone are the days when you had to dismantle everything, install complicated sensors, and above all, halt production. We can now collect all critical data while the machine is running at full capacity. It's a real revolution. What's more, the setup process is astonishingly simple. The technician simply connects to the electrical cabinet, and the results are almost instantaneous. With a single click, we can see the current performance, analyze torque and speed, and most importantly, detect the very first warning signs of a fault. We're moving from guesswork to certainty. However, the investigation doesn't stop there. A motor's performance isn't just about power consumption. There is another, even quieter threat coming from within: the gradual breakdown of its most essential protection. This is an issue that every manager should bear in mind, because the most dangerous failure isn't necessarily the most spectacular or the noisiest. No, it's the one that creeps in quietly until the day it's too late. This sabotage affects the engine's insulation system. You must view this insulation as a shield that is subjected to the onslaught of its environment. Heat, humidity, and vibrations, day after day. This genuine erosion weakens the very heart of the engine. And the greatest paradox is that the engine's operating environment is often its worst enemy. If it's too hot, the insulation ages at breakneck speed. If it's too cold, The bearings wear out prematurely and condensation sets in. As for humidity, it's public enemy number one. It seeps in everywhere. It causes short circuits and corrodes components. And when this silent sabotage goes too far, well, we end up with a catastrophic breakdown. A short circuit that doesn't just stop the engine. No, it literally destroys it. This disaster could, however, have been avoided.
So how do you fight an enemy you can't see?
Well, by giving yourself the means to see it, of course. This is where the logic is completely turned on its head. Rather than simply dealing with breakdowns as they occur, the aim is to anticipate them. We're shifting from reactive maintenance to a proactive approach. And here's the predictive tool that makes this possible. The CA6543 is a megohmmeter. It's an instrument designed specifically to track down hidden weaknesses in the insulation. It measures the quality of our renowned protective shield, and what's more, the results are crystal clear. It's a bit like a color-coded system for the engine's health. Above 1 gigaohm, everything is perfect. Between 100 megaohms and 1 gigaohm, it's fine, but we keep an eye on it below 1 megaohm. Warning, this indicates that a service is required. If we drop below 100 kiloohms, that's critical. The motor must be disconnected immediately to avoid disaster. And to be even more precise in the diagnosis, we use indicators and ratios. For instance, the DAR ratio detects moisture or surface contamination. The PI goes deeper, really probing the core of the insulation. These are genuine health checks for the equipment. This sentence sums it all up perfectly. The aim is to use energy and investment for production, not to cover losses or pay for emergency repairs. We stop reacting and start anticipating. Ultimately, this investigation brings us back to a fundamental question, one that every operations manager should be asking themselves. What are the hidden issues lurking at the heart of their own operations, waiting for just one thing: to be brought to light?